Welcome to this video on composite functions. If it's your first time viewing a StudySTEM video, consider subscribing if you enjoy this video. And if it's not your first time, then welcome back. So composite function, in textbooks, usually written out like this, right? And this is f of g, and this is just basically a notation for of, right? So we can just say that's f of g in parentheses over here. Okay, and we can define this as f of g of x, which we can write like this. Okay, so that's really what the definition of a composite function is. You just have some function inside of another function, right, in which you'll then evaluate. Generally, these, like your f of x will be given, and your g of x will be given, right, and some type of homework problem. All right, let's get into our first example here. We're going to have f of g of h. Okay, so let's just try to write this out. This would basically be this should be a g. Sorry about that. Okay, that is the same. It's just different notation. It's written in different notation form. All right, and if we define f of x as x plus 1, we'll define g of x as 3x, and we'll define h of x as 4 minus x. Okay, so first we need to plug this h of x into this g of x. So everywhere there's an x, this whole function, this whole h of x, needs to be plugged into that. Okay, so this would be what we're about to solve for. So it'd be 3 times, and then plugging in this whole h of x, 3 times 4 minus x, distribute, you'd have negative 3x plus 12. Okay, and now we need to find this, our final function we need to solve for. So we already have this part, so now we just plug this g of h of x into our f of x function. So we have x plus 1, everywhere there's an x, we have to plug this in. So it's going to be negative 3x plus 12, and then plus 1. Okay, and once again, distribute 3x plus negative 3x plus 13. And that is your final answer for that example. All right, let's try an example where x is defined. So let's define our f of x, or sorry, f of x equal to, x plus 5, and our g of x equal to x squared minus 3. And let's solve for f of g of 0. Okay, so let's plug 0 in our g of x. So 0 squared minus 3 is just negative 3. F of negative 3 plugged into every x. Hopefully that makes sense. As 0 is plugged into here, this negative 3 is plugged into here. Okay, so f of negative 3 is just going to be negative 3 plus 5, and that's going to be 2. Okay, so let's try one where f of 20. Okay, so f of 20 plus 5 is 25. F of 25, plug 25 in for x, it's going to be 30. So hopefully you're kind of getting the rhythm of things. You're always just plugging this placeholder, or this x, not placeholder, this x into the function that it is being evaluated into. Alright, and let's run into some more examples similar to our first one, but just make them a little more difficult here. So let's define our f of x as x minus 1 and our g of x as 1 over x plus 1. Okay, and this one, let's try to find, let me erase that. Let's try to find f of g of x. Okay, and our g of x is simply 1 over x plus 1. So this is going to be 1 over x plus 1 minus 1. And actually, let's put this up here. Okay, now let's try another example. We're going to use the same functions though, so f of x and g of x are going to stay the same. Now let's try to find g of f of 1/2. All right. Remember, these are our functions that we're looking at. Okay, so plug in 1/2 for x, which is going to be 1/2 minus 1. So this is going to be negative, or g of negative 1/2. And so you plug that negative 1/2 in for every x. So this is going to be okay. So we're going to have 1 over 1/2. 1 divided by 1/2 is 2. Okay. And let's try one more example on this. Let's say g of 2. So this is how you'd say g of 2. You're always saying g. Okay, so let's plug in 2, our g of x. Which is going to be g of 1/3. And plug that in again. And we're going to have okay, and if you don't really know what to do at this point on how to simplify that fraction, let's do a quick little lesson on this. This is the same as this, right? Which is just going to equal 3 over 4. Okay, and that's the end of that problem. I hope this video on composite functions helped you. Just remember, really all composite function is just combining functions into one. You're plugging in a different function as an input of another function. So hopefully that makes sense. But If not, please leave questions, and if everything makes sense, have a great day and consider subscribing. All right, thank you.